everyone, welcome to Breaking Barriers, Empowering the Future of Women in MSE. This is the second installment of the four-part outreach webinar series organized by the Department of Materials Science and Engineering at NUS. I'm Harini, and I'll be your host for today's session. Consistently ranked among the top globally by Times Higher Education and QS, MSE at NUS has made extensive contributions and breakthroughs in education, innovation, and research. It has clinched numerous awards both locally and globally, with cutting-edge research spanning areas like advanced manufacturing, bio-inspired materials, edge computing, and computational material sciences, as well as a team of world-renowned faculty members, including Professor Sir Konstantin Novoselov, Professor Antonio Castroneto, and Professor John Wang. It is no surprise that MSE at NUS stands as one of the foremost material science and engineering departments in Asia. Before we begin, let me introduce the Outreach webinar series. As part of the MSE Roadshow, this four-part series is organized with the aim of raising awareness and showcasing the diverse roles and career opportunities available to MSE graduates. Over the next few weeks, several distinguished speakers from various fields will each give a talk on the career pathways they have embarked on. The webinar will be split into two parts. The first will be the talk by the invited speakers, followed by the Q&A session where the panel of speakers, including Professor Daniel Blackwood, Deputy Head for Education and Student Affairs in MSE, will answer questions posed by members of the audience. Members of the audience may submit their questions in the webinar Q&A anytime and indicate if they would like a specific speaker to answer their question. Do also remember to complete the survey prompted at the end of the webinar. To kick off today's webinar, let's invite Professor Blackwood to give his opening address. Prof. Blackwood, please.
Okay, thank you, Harini. I will just share the screen. Slideshow. Okay, so welcome to the Department of Materials Science and Engineering. I'm Associate Professor Dan Blackwood. I'm the Deputy Head for Education. Right. So why come to NUS and not one of the other colleges in Singapore? Well, we're in the top 10 in the world as a university. We're the flagship university. We're the only really comprehensive university in Singapore. So that means that when you stay in halls of residence and things like that, you'll have friends from all the other departments and faculties in the university, maybe lawyers, medics, social scientists, arts, and that will give you a very large network. And after you graduate, you'll remain in Singapore. So this network that you build up while you're at university is likely to be as important to you as the education that you received. We also have world-class facilities at NUS. There are 6 research centers of excellence, all funded by the National Research Foundation and the Ministry of Education. We've got strong partnerships with industry and local government, and we are amongst the top for employability. In fact, the Materials Science and Engineering Department is for Materials Science and Engineering with the top amongst employer reputation in the whole of Asia. So obviously that includes Singapore as well. Why the College of Engineering? Well, we're in the top 8 for engineering programs in the world. We've just fused together 2 world-class schools, the engineering faculty and the architecture faculty. So we've become together and become the School of Design and Environment. That's allowed us to offer a very flexible and diverse curriculum. Right? So you can combine both design and engineering together. And we're using problem-based teaching methods. So we get you hands-on in the lab early. So it's not just all theory, it's theory and practice at NUS. We've dedicated research centers with 13 world-class centers for design and engineering, and there's a wide variety of programs. Hopefully you'll do material science and engineering, but you'll find that it's actually easy to switch between departments. So we have students that come into our department from the departments, and a few even decide to leave. Hopefully more come than leave. So what about material science and engineering? What actually is that? Well, as the name implies, there's a lot of science. So there's physics, chemistry, and some biology as well, and some engineering. So it's a practical science where we look at energy, the biomedical fields, 2D materials, and even robotics. So if you like science, but you want it to be applicable and useful to society, then material science and engineering is probably the subject for you. Why MSE and NUS? Well, we are a small cohort each year. That means we are a close community and the staff can get to know the students. You're not just going to be a number. Okay? Indeed, all of you will be given a mentor. An academic staff will be assigned to you, someone you can talk to not only about your academic issues, but if you have any personal issues as well, it'll be a friend that you can talk to. We also have a good male to female ratio. It's not male dominated like many of the other engineering departments, and obviously that's what today's talk's about. We're the only department, or the only department in the whole of Singapore that has a Nobel laureate working with us, so you potentially have a chance to do some research for the Nobel laureate. Nowhere else in Singapore can you do that. We have a good student club and we strongly support that. For some strange reason, we've had a lot of international bowlers in our department. So there's some correlation between 10-pin bowling and materials. We have good partnerships with industry and the institutes. There's an Institute of Functional Intelligent Materials and 2D materials. And also our students get on and do good career prospects, as I'll talk a little bit more about later. A little bit of history of the department. We started off as a program between physics and chemistry back in 1991. So that shows where our science basis is, right? And then we became a full-fledged department in 1996. That's when I actually arrived in Singapore, so before most of you were born. And we spent the next 9 years in the Faculty of Science. And then the university decided that we should actually take our scientific materials knowledge and make it more application oriented. So in 2005, we moved to the Faculty of Engineering. And of course, a couple of years ago, the Faculty of Engineering was merged with the Design Faculty, and we became the College of Design and Engineering. We're a top research department. Worldwide, every year, they look at the top 1% of influential scientists. And there are 6,849 of those worldwide. And in NUS, we have 43, which is more than 5%, so which is very good, right? If you think of the number of universities in the world, there's probably nearly 1,000. For us to have around 5% of the top researchers is very good. And then in the department, of that 43 that are top in NUS, we have 3, which is about 7 or 8%, and we're only a small department. So again, that goes to show how top of the department we actually are. We're also the only department with a Nobel Prize winner, and the university and the government are actually funded to the tune of about 200 million to set up the world's first institute dedicated to functional intelligent materials. Basically, they're using AI to develop new materials. So if the government and the university together are willing to spend 200 million on materials, clearly it's an area that they consider to be very important for the future of Singapore. What about specializations? Well, we have 6 specializations at the moment. One is on materials for sustainability and energy. So that's things like batteries, for water resources, all the things that you hear about in the news about fighting climate change. Nanostructured materials and nanotechnology. We have one with robotics. For the robotics, we joined together with the departments of mechanical engineering, electrical engineering, and biomedical engineering. So students that take the robotics will not only take our courses, they take courses from those departments as well. Then there's the one on functional intelligent materials that's using AI to develop new materials. And that's going to be in collaboration with this new $200 million institute. We also have a specialization with biomedical materials, where we join together with the biomedical department, and also microelectronic and quantum materials, where we join together with electrical and you can see from the fact that we've joined together with other departments to make these specializations, which actually shows that materials are actually fundamental to most other engineering departments as well. So we're very much cross-disciplinary in terms of using materials. In terms of resources, well, we've got a very good curriculum, which will get you not only hands-on and theory, but also will teach you some entrepreneurship as you go through it. Our department's got cutting-edge research into future energy materials, AI of materials, as well as some biomedical materials. And we've got good contacts with industry, our alumni, and an international network. And that will all be helpful when it comes to for you to get in a job. What will you actually do when you're here? Well, all our engineering students now in the college, we all do the same Common Core curriculum. So most of your first 2 years will be Common Core. You'll just do 4 courses that are related to materials. So on top of that Common Core, you then build your materials knowledge. And then on top of that, you either do a specialization or 2 specializations perhaps, or you can do a specialization and a minor. Perhaps biomedical engineering is your minor, or it could be data engineering, or you could do a second major. Okay. And this is some of the jobs that maybe you'd end up with, anything from a health professional to a patent lawyer. You could work in aerospace engineering, or maybe into sustainability. All those areas are going to need materials. And you can broaden your skills even further. You can do a double degree with business administration. You can get onto the Doctor of Medicine program with Duke NUS, or you can do a double major, perhaps in innovation and design, or you could actually do a double major with another engineering department. We just have one student that's doing material science and engineering, and his second major is electrical and computer engineering. And then there's a whole host of different minors that you can do, from computing and data analysis to Japanese, if you like. That's one of the great advantages of being a comprehensive university, is you can do all these extra subjects that you'd never thought of doing before you came to university. There's also special programs like the Engineering Scholars Program, which is an accelerated 3-year course. So you'll take all the same modules that you would if you were doing the 4-year course, but you cramp it into 3 years. And then after that, you'll do a 1-year master's course. And you also have priority if you go on that to work in the NOC, that's the US Overseas Colleges, or the Overseas SEP, so that's when you go to other countries to do 1 semester. You'll get priority on that. You get accommodation on the campus, and you get some money, or at least your fees are paid for you. There's plenty of overseas and industrial opportunities when you come to NUS. There's the student exchange program. I was struggling to remember what SEP stood for just now. We have students that go all over the world. We're the only university that actually has programs with both Oxford and Cambridge. So if you want to go to the top UK universities, which obviously I'm going to, being from the UK, I'm going to recommend, then NUS again is the only school you can go to. We have the overseas colleges all over the world where you can go and work for a startup. And in MSE, we've actually now coming up with an MSE Study Award that we will give to up to 6 students a year, and that will be for $20,000, which will help cover your fees over the 4 years. Okay, so we've just come together in our department and decided that we will actually encourage more students to join our department by paying some top students an allowance. And if you want, then there's employment, right? Will you get a job? At the moment, the answer seems to be yes. Last year, nearly 93% of our students had jobs within the first 6 months. So we have a high employability. That's what I already said, that we have a good reputation amongst local employers. Salaries actually went up last year. Right? The mean salary for our graduates went up nearly 13%, and the median up by over 15%. So our graduates got a bigger pay rise last year than I did by quite a long way. So the salaries are actually competitive with all the other engineering departments. Slightly higher than the other colleges that offer material science and engineering, I could say. This is some of the companies that employ our graduates, and they all range from the materials engineering area companies like Bosch, Applied Materials. There's aerospace in here, like Bombardier. There are the oil industry. There are the research areas like A-Star. Microelectronics is still a large employer of our students. There's also the banking, okay? About a third of our students leave engineering and go into areas like banking. And there they find that the analytical thinking skills they've learned while they were studying MSc are very useful to them. So they actually do very well there. But you can also, by looking at this screen, see that MSc is useful for just about every industry. So it doesn't matter which industry's doing well or doing badly in a particular year, there should still be jobs available for MSc students. There's also the webinar series. So I'm onto that page now. We're actually at this second one where we're looking at women in MSc. Like I said, we do have a fairly good gender balance in the department. And then on next week, we have a chance for you to talk and interact with a Nobel laureate. Again, something you can only do in our department. And then our third one on the 1st of March will be how we are revolutioning MSc in our department. If you want to know more info on that, you can scan the QR code. Okay, I'll leave it on the QR code just a little bit longer for you to scan it. You can also find out from that QR code a little bit more about this particular student award that we're offering. And with that, I will hand it back to Harini.
Thank you, Prof. Blackwood, for sharing about our department and the opportunities available for the students here. In today's webinar, we are fortunate to have with us two remarkable women in MSc who share more about their experiences in the STEM field. They are Professor Sylvia Gradacek and a current MSc student, Chua Su-hui. Thank you so much for joining us today. Firstly, we are delighted to introduce Prof. Sylvia Gradacek. Following the completion of her PhD at EPFL Switzerland, Prof. Gradacek has held prestigious positions at Harvard University and MIT before joining our esteemed department at NUS. Presently, she serves as the co-director of the Applied Materials NUS Advanced Materials Corporate Lab. Furthermore, she has played a pivotal role in the establishment of a cutting-edge electron microscopy facility here at NUS. Her research pursuits revolve around the synthesis of nanoscale structures and their integration into devices for applications spanning nanoelectronics and nanophotonics. Prof. Gradacek's illustrious career has garnered numerous accolades, including the NSF Career Award and the 3M Innovation Award. We are honored to have her here today to share with us her research interests and her experience as a leader in the MSc field. Prof. Gradacek, please.
So hello, everybody. Welcome again. And Harini, thank you so much for this kind introduction. So I would also, again, like to welcome you to this webinar today. And it's really a great honor for me to be here today. Again, my name is Sylvia Gradacek, and I joined NUS in 2019. And I would like to share with you briefly about my path and why I decided to be a material scientist, as well as to tell you about some of the aspects of my research, and also share with you what I think about the diversity and why the diversity in the material science and engineering disciplines is very important. So we are currently part of the material science and engineering department, and I sincerely hope that many of you, and at least some of you, will become a member of this department in the near future. And we all have different paths of how we make the choices in our life and how we make the decisions about our career paths. And in the first part of this presentation, I would like to share with you how, again, I came to this point. So this is the part of the presentation that I called connecting the dots, because every time when we make the choices about our career paths, we don't necessarily know what will happen in the future, but at a certain point, we do try to think about how we came to that point, and then all of these dots connect with each other. So today, I would like to tell you about my dots. So then again, I will briefly tell you about my research and what I'm currently doing and what I'm passionate about. And I will tell you about some of the career paths that my students have taken being material scientists. So as it was mentioned, I'm originally from Croatia, and many people, when you do think about, or when you mention the word of Croatia, they think about an amazing soccer team that is winning the World Cups. But not many people know actually this very small country of about 4 million people was the birthplace of Nikola Tesla, one of the greatest engineers of all time. And Croatia was also the birthplace of two Nobel Prize laureates. Personally, I was the first in the family to graduate with a university degree, and I had fellowships, and I worked during my undergraduate studies to support my studies. So I also engaged intensively in final year projects, and I volunteered to work at different types of research projects during my studies. For some of the efforts, I was also rewarded the President's Award for the best undergraduate project at the university at that time. And there are a couple of things that I learned as an undergraduate student that I would like to share with you. So one of the things and one of the reasons why I was very passionate about physics at that time is because I was a very passionate astronomer. And I really liked astronomy, astrophysics, and I would use these amazing telescopes to look into the space. But there are a couple of things that I learned as an undergraduate student. So first of all is that finding opportunities and taking initiatives to be engaged in research is very important. And this is one of the things that our department indeed here at NUS does offer to US students. It is also important to work as a part of the team. I was very lucky to be part of a team that organized astronomy expeditions to Mongolia, and being part of the team and having a society and having friends that are supporting you is extremely important. Again, some of the things that material science and engineering department here at NUS indeed does offer. Also, what was mentioned by Professor Blackwood earlier today is the importance of mentoring. So one of the things that I learned as an undergraduate student is that having mentors and someone who can support you is extremely important. And again, I would like to emphasize that material science and engineering department here at NUS does provide these mentoring opportunities, both from the faculty members, but also your colleague students. Eventually, I did pursue my studies in material science. So I started to study physics as an astronomer, but I was really very much interested in practical applications. I really liked doing things with my hands, and I was thinking about what are the disciplines that do allow me that opportunity. So material science was the area that I became very passionate about as a graduate student. So I replaced these huge telescopes with huge microscopes, and I changed the scales. So instead of looking into something that is very far away and extremely big in terms of the scales, I started to use these special microscopes that now allow me to study the materials at the very nanoscopic and even atomistic scales. So some of the things that I learned as a graduate student is that it is extremely important that we broaden our horizons, that we have an open mind about our careers, that we have to think about the mobility and among disciplines, among places where we conduct our studies. And again, don't be afraid to take chances. So I really hope that regardless of what you're really thinking about right now, but in terms of your careers, that taking a chance and thinking about the material sciences as a potential major for you is one of the things that will guide you through your decision-making process. After finishing my PhD studies, I did spend a couple of years at Harvard as a postdoctoral fellow, and then I started my academic career at MIT. And one of the lessons that I learned at these two places is extremely important to surround ourselves with excellence. What that means is that it's extremely important, and we will propel as individuals if we do surround ourselves with exceptional individuals and teams. Again, one of the reasons why I eventually decided to join NUS in 2019 is because NUS does offer that excellence. So NUS provides the world-class infrastructure. It allows us to collaborate with industry. Singapore and NUS is one of the rare academic places where this industry academic partnership is extremely strong. And we are here surrounded by amazing students. So NUS really allows you and enables you this. It is one of the great places where you can surround yourself with excellence at different levels. In terms of the research and the types of studies that I conduct, my research focuses on nanostructured materials. And Professor Daniel Blackwood talked about what the material science is, and it is a cross discipline that is a merger between different scientific and engineering disciplines. How we like to think about material science is it is a discipline in which we really can correlate the structure of the materials with their properties and performance, and we do this through processing. My research focus is on connecting all of these components in nanostructured materials. So just to give you a feeling, and I will talk briefly about why we are interested in nanostructured materials, but when we do think about material sciences as a discipline, we are really trying to think about how we can synthesize these materials. What are the tools and specific ways how we can synthesize the materials to change their structure. So how do we take a piece of material and through the synthesis means we can change their structure? Because I do work in the field of nanostructured materials, then understanding how that structure changes the properties of the materials involves a lot of tools that enable us to study the properties of and the structure of the materials with high spatial resolution. What that means is that we are developing new tools to study structure of the materials with the atomic precision. And eventually, these new and exciting materials have to be applied for specific applications. In my research, I'm driven by typically energy-related questions. And this is one of the examples of solar cells that we developed that is a transparent solar cell. And you don't even see it in this particular figure because it is transparent. So the solar cell is a device that collects the light from the typically solar source, and it transfers it into electricity. And typically, we were excited to develop solar cells that are transparent, that can function, for example, on the surfaces of windows or buildings and still collect that sunlight and turn it into electricity. So I told you that I'm very much passionate about nanostructured materials. And nanostructured materials exhibit unique properties by virtue of their low dimensionality. What that means is that typically when you do think about the material and how you change the properties of the materials, typically you would change the composition of the material. You would mix different types of materials and you would change the composition of that material to change the property. Nanostructured materials, on the other hand, also enable you to change the properties of the material simply by changing their dimension. What that means is that, for example, by shrinking the size of the nanomaterial, you can change the property. Or, for example, the nanostructured material has very high aspect ratio. The material can be very long in one dimension, but small in the other dimension. Or you can change the surface to volume ratio. What that means is that nanostructured materials have relatively large surfaces, which is very important, for example, for sensing applications. So you have this large surface of the nanostructured material that enables you to interface that material with the environment and yet collect the information about that environment. One typical example that I like to emphasize is the question or the example of nanostructured nanoparticles or quantum dots, which was the discovery and the ability to tune their properties was awarded a Nobel Prize last year. So the Nobel Prize in Chemistry was for the development of nanoparticles. And this particular example shows you that even if you have the single composition, so you don't change the composition of the material, it is the same types of atoms, it's the same compound, but you simply change and shrink the material, the particles and the color that they emit will change. So this particular example here shows you how you can, by squeezing the size of the nanoparticle from 6 nanometers in size to 2 nanometers, the color of the particle changes from red to blue. And nanoparticles have been used throughout the history, even without knowing that we are using nanoparticles. A very famous example is the example of stained glass. So the stained glass is the glass that has very similar composition as the transparent glasses that we use in windows, and yet they have these beautiful colors. And this is an example from Notre Dame de Paris, which was built in the 13th century. So all of these pieces of the glass were glasses that were produced by mixing metal cells with transparent glasses to change their color. And for many, many centuries and for many, many years, people would do this. They would empirically mix different cells and obtain these very unique colors of the glass. And they would do this empirically without really knowing what is happening with the glass. What is the underlying structural reason why these glasses are changing the colors? And Only now, only relatively recently in the 20th century, we were able to understand why the glass has different color if you change or if you introduce different cells. And the reason for that is that by embedding different metal cells into the glass itself, you produce these metallic nanoparticles of different sizes and compositions. So this particular image that I'm showing in the corner of this slide is a transmission electron micrograph image of a metal nanoparticle that we typically find in these stained glasses. So throughout the centuries, people would use nanoparticles without knowing that they're using nanoparticles, and only by the development of new tools and understanding the material science, we now have the ability to control them. And even this discovery was awarded the Nobel Prize last year. So in my research group, we take advantage of these nanostructured materials to provide and develop different types of applications. And I'm very passionate to work on the problems that do matter. I already mentioned to you these applications of the solar cells. And the reason why I became very passionate about this is because of the sustainability and the energy-related matters where the material science indeed can influence the world in which we live. So we developed these flexible and transparent solar cells in which each individual component of the cell was designed using nanostructured materials for improved efficiency. Just to give you an example, we use here graphene as an electrode. This is the layer of the material that collects the electricity. We use nanoparticles to absorb the light from the sun and transfer it into the electrical current. And we use nanostructured nanowires to conduct that electricity. And each component of this solar cell is based on a specific nanostructured material, and each component was specifically designed to optimize its performance. Nanoparticles have high absorption. They can transform light very efficiently in the current. These long nanowires conduct electricity very effectively, and graphene electrodes are very flexible and transparent, and they enable us to make these devices being very transparent. This particular work attracted a lot of media attention, and I was given an opportunity to work with Professor Munji Bhavandi, who was the Nobel Prize winner last year for the discovery of nanoparticles. So we published many papers together in this particular field. This particular work also enabled me to work with colleagues from different domains, not only material science, but chemistry, electrical engineering, physics, earth and planetary sciences, architecture, etc. The reason why I'm mentioning this particular example is to tell you that material science is highly interdisciplinary. And if you have a problem that intercepts other disciplines, you have an ability to work with other departments here at the College of Design and Engineering and implement your ideas from material science field to many different domains, including some of the domains that are typical and conventionally not being considered as being dependent on material science, like architecture. So it's a great pleasure for me, for example, to work with colleagues from the architecture department in the ways how we can implement these unique solar cells for building applications. Another example that I would like to share with you that is very attractive and important for my research right now is in terms of downscaling the transistor and electronic devices. So the transistors are the common components or the brain of your computer or a mobile phone. And the very first transistor was developed in 1947. The size of the very first transistor was of the size of a hand. So this transistor would fit into the palm of your hand. Right now, the size of a typical device that you find in your computer is 1 million times smaller. So it is so small that the position of individual atoms start to matter. So we study these transistors and we are trying to understand how we can make them even smaller and how we can optimize their performance. And this is critically important, and this scalability is very important to understand because the initial transistor was 20 centimeters in size. Now it is 10 nanometers in size. And we start to appreciate this downscaling by thinking about how the technology that we use in everyday life right now would look like in historical perspective. So if you take a typical example of a phone, and if you think about all of the functionalities that your phone has, it can take photos, it can memorize these photos, it can stream the videos, it has large capacity to store the information. And if you think about that particular device, and if you were to build that device using the technology in 1980s, that particular device would cost $100 million and it would be large as 14 meters. So if you take a functionality of the phone that we right now, each person in the world is holding in their hand, if you think about how that device would look like 20 or 30 years ago, it would cost $100 million and it would be as high as a building. So what that means is that the scaling and the expectations of the device that we use in everyday life was enabled by material science. So we do have these functional devices and we have certain expectations out of them. And the demand for computational powers will increase even further. So there is a boom in the data generation that is required by smart homes, smart vehicles, and the material science will be the driving force to enable that. So we currently work on the development of new materials and new types of devices that can enable that scaling and in making these devices even more efficient and even smaller. So a couple of other examples that I work on is the development of very efficient light emitting devices based on quantum dots. This is just an example of the light emitting diodes that we have been able to develop using these quantum dots. We are also working on understanding how we control the material properties even beyond composition and the size. So there are new ways of controlling the materials by using relative twists of the materials. So this is an emerging field of material science that I'm very passionate about. So regardless of what is your passion, where do you would like to go in future, what are the grand challenges that you care about, whether you're really passionate about energy, about health and medicine, human technology transfer, material science is the core. But the question is where you find your passion. And my strong belief is that each individual will find their passion, and we have to provide them the tools that will enable them to follow their dreams. So these are the examples of my students who pursue different types of careers. Some of them are academics as myself. Some of them started their own startup companies. Some of them work as financial advisors. One of my previous students works as a science policy maker, and she at certain part of their career worked as an advisor to the President of the United States, as a staff member of the White House. So they are all educated as material scientists, pursuing their own careers. So I'm a strong believer in the diversity in material science, and many studies have shown that men and women do have different approaches to solving complex problems, and having this diversity of opinions is extremely important. And we are very proud in material science department that we value this diversity and encourage it. You will make a difference in the world if you pursue material science studies. You get to be creative because of this interdisciplinary nature of the material science. You will have plenty of career options, and engineers are paid well. Professor Daniel Blackwood did mention that our alumni and students do find good opportunities in their careers. I'm personally very passionate about mentoring undergraduate students, specifically women, in material science and engineering. And this is something that is very evident in our department. By joining our department, you will have the privilege and opportunities to take advantage of these opportunities. With that, I would like to thank you for your attention, and I will be happy to answer any questions that you might have at the end of this 1 hour session. Thanks.
Thank you so much, Prof. Karachek, for that informative sharing. Your experience is surely an inspiration for all the aspiring young women in MSE. For our audience, do note that the Q&A session will be held towards the end, where the speakers will answer the questions that you submit. Now allow us to introduce our next speaker for today, Chua Su-hui. Su-hui is currently a second-year undergraduate student who's passionate about her studies in material science and engineering. It is complemented by her minor in computer science. She possesses a deep commitment to exploring new horizons and embracing diverse experiences. Her active involvement includes serving as the secretary of the MSE Club and enthusiastic participation in hackathons. Presently, she's embarking on a research journey as part of the Undergraduate Research Opportunities Program, Europe for short, and she's focusing on material synthesis for wearable technology. We are happy to have her here today with us to share more about her experiences as a student in the MSc department. Su-hui, please.
Thanks, Harini. Could you stop the share screen so that I can share my screen? Thanks. Okay, so hi everyone. So I'm Si Hui, a year 2 student studying material science engineering. So for today, I decided that I should just share about how my journey has been so far at NUS MSc, and hopefully that gives you some information of how it will be like. So a bit of a background of myself. So I was a JC science stream student at Rio Valley High School. I love chemistry and increasingly have an interest in technology. Thus, I pursue a minor in computer science. And currently, I stay at a hostel called Tembusu College, which is a residential college in NUS, and also join some CCAs. So if there are any questions regarding university life outside of MSc, you could just ask in the Q&A session later. So for today, the content will be split into 3 parts. So first, I will explain why MSc, why I chose MSc, and why NUS MSc. Secondly, will be how's my NUS MSc like after 2 years being here, and concluding talks about what I think, concluding thoughts in relation to the webinar. So a brief background of myself will be that actually when back then when I was also trying to choose my courses, I was truly clueless on what I want to choose. So after reflecting some potential ones and thinking about it, I decided to choose MSc for as part of my top choices for the following reasons. So firstly is the idea of application. So because material science and engineering is a form of engineering, so it's concerned with the application of knowledge or theories like say chemistry or physics to do something such as creating or modifying materials to address an issue at hand. So the idea of engineering solutions to solve an issue is something that appealed to me. And because I was interested in chemistry and I know that MSc involves some form of chemistry, so I decided, so that's why MSc was part of my choices. I think the last point will be that is, as the speakers have mentioned, it's very broad and interdisciplinary, because at the end of the day, materials are everywhere and truly an integral part of any objects of design. Yeah, just like it's like our raw ingredients. So I mean, after all, like let's say for example, like a thermal flask. So what allows the thermal flask to retain the heat of the contents in the bottle is also dependent of, in the first place, what how conductive the material is, and perhaps the design of the bottle that allows this insulation. So all these materials does play a role in here, and because of these broad implications materials hold, that's why I chose MSc at the end. So we keep saying about interdisciplinary, so I just wish to show an example how what we meant by interdisciplinary in like material science and engineering. So for example, let's say that we have say we want to design a medical stance, which is a device that's inserted in the blood vessel to open up the blood vessels if the opening gets too narrow, right? So in terms of the many, so how are the multiple disciplines are involved? It could be like, say if you want to design a stand, what is the chemical composition of the stand should be like? So should it be a metal or polymer or what? And then because stents has been meant to be inserted into the blood vessel, the stent needs to be biocompatible in that sense that it does not harm us to our health. And so thus understanding how the introduction of the stent or such material may affect our tissue response, whether it may trigger inflammation, immune reactions, and whatnot, is something to consider. And so understanding biological and physiological processes may become under the purview of MSc because of how these stents might be applied to. And since stents needs to be strong and flexible enough to withstand the pressure due to the contraction of the blood vessels, so understanding how this material allows the mechanical so understanding the mechanical properties of the material, such that how can we make this material strong and flexible, is something that we need to consider as well. And lastly, it will be how to design or optimize a stand design such that it fulfills the supposed functions and properties. So this is how many different kind of disciplines may come together when it comes to say material science and engineering. So the most unique thing about MSc in my opinion is that because materials is like the foundation of the raw materials of any physical solution, it does have a lot of potential to make groundbreaking innovations, which from my reading the news and stuff like that, I will show 2 examples that's really struck me the most. So firstly, this is in year 2020. So okay, so for now, currently if we drop our phone phones, right, and the screen cracks, and therefore we might need to go to the repair shop and repair it, or just leave it with the cracked lines. But given this article, they say that there's a new invention, there's possibly a new possibility that if there's a new material. So if the phone is being dropped and the screen crack, what happens is that the screen may repair by itself because of the material. So the cracks are healed. So what intrigued me was that materials innovation uniquely offers the possibility of what if cracks does not really matter in the future. So the kind of things that materials innovation, the kind of opportunities of innovation materials engineering kind of offer is something that appeals to me in that sense. So another one will be like batteries. So currently the batteries that we know is something like this. It's like a container, if I must say something, I must describe, and there's a certain size and stuff like that. But given the technology nowadays, not necessarily it has to be the case anymore. So what if we can make it smaller and maybe even make it into a fiber instead, like a battery fiber? So there's this group of MIT engineers, one of whom is now an assistant professor in MUS MSE, design batteries that could be in a fiber form. To be frank, I didn't really read too much in depth of what this really meant, but potentially what I think is that batteries maybe can be woven or integrated into our clothes. And that really means a lot of things. For one, instead of like using our health monitoring trackers or watches nowadays, right? Maybe instead our shirts can help us do that because of how batteries can be integrated in the clothes and stuff like this. There may be some distance away to realize this reality, but through these two examples, just want to illustrate what it means when we say that materials could be the one driving innovation. And also to recall history, many of our scientific progress has been due to the advancement of our materials as well. I mean, there's Stone Age, Bronze Age, Iron Age. And to think about it does wonder, like, what if, say, stainless steel wasn't accidentally discovered? Does it really mean that the cutlery that we use today, the materials, does it mean that we have to taste the rust because stainless steel wasn't available? And what if like glass wasn't discovered? So because like, or transparent objects in that sense, because like lenses are pretty much key to a lot of our inventions nowadays, like our glasses and our microscope and stuff like this. So if these materials have not been discovered, then what kind of progress could society make in the first place? So the importance of materials in scientific progress is really very apparent here. And a side note would be that all these wonders and admiration of materials I have has been largely influenced by this book. So if you are really, really interested in science history or just materials generally, I highly recommend this book. So these are the reasons why I chose MSc, because of the application, because it involves some form of chemistry and it's broad and interdisciplinary. So why exactly NUS, right? Personally for me, before I joined NUS MSc, the reason why I chose NUS is because of the fact that there's a flexible curriculum as mentioned. So at the point in time, I didn't really know whether I want to pursue a minor or second major or what. So the opportunity to think later, to decide later is something that appealed to me. And also NUS does offer a bigger range of second major subjects that we can choose from. Yeah. As for the two reasons stated below, small class size and community, it is something that I will say that when I was like going to open house and stuff like this, I do hear a lot of times, but it is these reasons I start to appreciate a lot more after I come into NUS MSc. So I will first share with you how my NUS MSc has been like. So back in year one, one of my key highlights is that the fact that in year one we can design our experiments. So back in year one we have to do lab work as a team. But what was special to me was that we are able to design our experiment, to design what we want to investigate for the last lab we did as an extension to the previous labs. So that opportunity and freedom to even design in the first place, I think it was very fun and it's, in my opinion, hard to come by. So for my group, what we did was to investigate the electrocatalytic activity of ZIF-8, which is a metal organic framework, or you can just think as a chemical molecule, or nickel foam and graphite electrodes for the potential application for supercapacitors. So these are some of the pictures that I took when I was doing my year one lab experiment work. And we also had the opportunity to use some characterization equipment that isn't necessarily very easily accessible or freely available. So it is a opportunity or something hard to come by for the very fact that we are able to access in year 1, in my opinion. So some of the characterization equipment was like the scanning electron microscope or the energy dispersive X-ray spectroscopy and like X-ray crystallography also. So for me, I did undergrad research opportunity program. Because I just started, I really cannot say, I don't have really a lot to say, but my project is about the development of magnetic fibers for wearable technology application. So in essence, for material synthesis, what we are looking at is how we can synthesize magnetic polymers. So currently, polymers are like plastics, so it is not magnetic, right? But we can do some processing towards it, such as integrating magnetic particles into the polymer and make a polymer that has a potential to be magnetized and become magnetic. So it's like synthesizing a magnetic polymer. So this is some of the pictures that I took during the research. Yeah, so this picture on the right, the black one, is like the so-called magnetic polymer, but it has not been magnetized yet. Yeah, so after going through magnetization, there's a potential for the polymer to become magnetic. Yeah, so that's my Europe so far. So another second most important point of why NUS MSc will be like, because it's the community. Like I mentioned, because I spent a lot of time to say that why I choose NUS MSc is because of strong network and small class size. During then, when I choosing university, these weren't really my top considerations. But after coming to uni, after attending lectures that could possibly to have hundreds of people, I start to appreciate why small class size is really, really great, because the amount of attention that each prof can give to the students and the environment in which we attend lessons is just very, very different. So one of the difference will be quite distinct will be that instead of like the usual classes where we see each other, because it's just the class size is so big that we see each other as like strangers sometimes. So when I come for MSc lectures, what we see here is that more like we see our friends or our classmates that we frequently meet. So it doesn't really feel that distant in that sense. So for the community here, well, I think it has been quite wholesome so far. I mean, we are dedicated prof and lecturer who really, really put in their best in explaining and addressing our consultation questions. Maybe perhaps because it's our small class size, that's why there is such a possibility, in my opinion. And perhaps also because of the small class size again, it is quite common, in my opinion, that sometimes we do greet each other, like greet with the lecturer to say hi or bye. And to me, that makes the learning environment more makes the learning environment having a human touch. So that's something that I appreciate a lot as well. And as said earlier, there's this NUS Material Science and Engineering Club, which aims to serve the needs of welfare of MSc students. So sometimes the club will organize events for us to bond together, such as sports day. And because I'm part of the club, sometimes when discussing with professors on these organizing these events, sometimes the prof will take time to show concern or say that whether we overstretch ourselves, etc. So the warmth that I feel in this MSc community, I feel it very, very strongly, and something that I appreciate as well. Yeah. So as mentioned by I think the first professor that said the department is very highly supportive of our student initiative, and I feel that I could attest to that, because I have friends who have very interesting ideas and new initiatives that want to implement, and so all these initiatives tend to get approved usually. So this shows that the department is really very receptive to the new initiatives sometimes students propose, and this is something that I appreciate as well. So some of these initiatives is called like the year 1 cohort bonding that we had. So the department was very supportive in offering the budget funding and stuff like this, and also try to come up with a new CCA that I'm currently in, which is called the NUSME Conductor Society. Yeah. So these are the other things that I do as well. Like I joined hackathon. So Health Hack 2024 was a health tech related hackathon that is still currently ongoing actually. Yeah. And then I also participate in my hostel activities like team mentors, which is to mentor the secondary 4 students in their academic subjects and stuff like this. So if there are any questions relating to this as well, you can ask in the Q&A session later. So in conclusion, to relate to the webinar title, to be honest, I didn't really feel very different to say like whether or not I'm a female or not, because maybe because the gender ratio in MSE cohort is truly nearly 1-to-1. So I don't feel any much difference in that sense. So it's like, in my opinion, it's like the same lah. And observation will be perhaps that I feel that companies seems to be trying hard to attract more female STEM students already. So for example, there's this Micron Global Women Mentorship Program. Their company visits that are meant for females as well. So if I'm not wrong, in the webinar synopsis, there's this part on how can we, exploring how women in MSc can continue to break boundaries, lead innovation, and inspire the next generation of scientists and engineers. I might have not been too direct in answering the question, but my personal opinion is that I think it's really about continuously looking out for and seizing opportunities, regardless of who we are. So I mean, we can always participate actively in MSc courses, try to take part in some NUS programs like semester exchange program or Europe that I mentioned earlier, or just being involved in CCA, or we can just don't do any of it and just study and stuff like that. It's really up to you, how you want it to go. But I would say that NUS does really offer a lot of opportunities, which I only mentioned like a slice of it only. And MSc helps in that sense that there is this warm and inclusive environment for us to learn, work, play, and grow lah. Yeah. So to summarize, right, in one word, why MSc is we broad, and why NUS MSc is really because of the community. So now I share with all of you like how my experience has been like and stuff like this. But really, I think to say like, but really the question at the end of the day really instead is, what's yours you wish to create? Like, what's your experience that do you really want to create? And with that, I end with my presentation. So if there's any questions, you may feel free to ask in the Q&A or just email me at this email. Thank you.
Thank you, Su-Hui, for offering prospective students a glimpse into life at MSc. Your insights and experiences are undoubtedly invaluable to them. So we have now come to the end of today's session. On behalf of the organizing committee, I would like to extend our heartfelt gratitude to the speakers for taking time out of your busy schedules to attend today's session. We thank our audience for your participation and hope that this session has been fruitful for you. We look forward to seeing you in the upcoming session, a conversation with the Nobel laureate in MSc, which is to be held on the 21st of February. Please take a moment to complete the short survey, which will appear right as you exit the webinar. And also do scan the QR code on the left to join our MSc Discord, or the one on the right to find out more and contact us if you have any further questions. Thank you and see you soon in the next webinar.
Okay, bye then.
Thank you. Goodbye.
Thank you.